Preparing for a software engineering at Netflix interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a highly available video streaming service like Netflix? I would separate playback, identity, catalog, recommendations, billing, and content delivery into independently deployable services. Video files would be encoded into multiple bitrates and distributed through regional CDNs, while APIs remain stateless behind load balancers. Multi-region replication, automated failover, caching, and circuit breakers would protect availability. I would measure startup latency, rebuffering, error rates, and completion rates. The design favors availability during failures, accepting eventual consistency for non-critical metadata. While answering, cover service decomposition, content delivery networks, adaptive bitrate streaming, multi-region deployment, caching, observability, graceful degradation, and how you would balance availability, latency, cost, and consistency. Question 2. How would you handle failures in a distributed Netflix service? Distributed failures are inevitable, so I design for isolation rather than assuming perfect dependencies. Every remote call gets a bounded timeout, carefully limited retries with jitter and circuit breaking. Bulkheads prevent one overloaded dependency from consuming all threads. For recommendations, I might return cached or generic results. For payment, I would fail safely and avoid duplicate charges through idempotency keys. I would validate these behaviors with fault injection and production-style load tests. Make sure to cover failure domains, timeouts, retries with backoff, circuit breakers, bulkheads, fallbacks, health checks, chaos testing, idempotency, and distinguishing transient failures from systemic overload. Question 3. What is a circuit breaker, and where would you use one at Netflix? A circuit breaker stops repeatedly calling an unhealthy dependency. In the closed state, requests flow normally. After failures cross a threshold, it opens and fails fast. After a cooldown, the half-open state permits limited probes. At Netflix, a recommendation client could return cached suggestions while its dependency recovers. The breaker must work with timeouts, bounded retries, and metrics. It limits blast radius, but engineers still need to investigate and repair the failing service. In your answer, explain closed, open, and half-open states, failure thresholds, recovery probes, fallback behavior, timeout interaction, and why circuit breakers prevent cascading failures rather than fixing root causes. Question 4. How would you design adaptive bitrate streaming for millions of concurrent viewers? I would encode each title into several resolutions and bitrates, split every rendition into short segments, and publish a manifest describing them. The player measures throughput and buffer health, then requests an appropriate next segment from the CDN. It should switch downward quickly when bandwidth drops and upward conservatively. Segment duration affects responsiveness versus request overhead. I would optimize for minimal startup delay and rebuffering, not simply the highest possible picture quality. Be sure to mention video segmentation, multiple encodings, manifest files, client-side bandwidth measurement, bitrate switching, CDN caching, startup delay, rebuffering, and trade-offs between quality and bandwidth usage. Question 5. How would you design a recommendation service for Netflix? I would use a two-stage architecture. Retrieve a broad candidate set using collaborative, content, and popularity signals, then rank candidates with a learned model. Offline pipelines would train from viewing events, while an online feature store supplies fresh context such as device and recent activity. Results would be cached by user and profile, with fallbacks for new users. I would evaluate watch satisfaction and retention through controlled experiments, while protecting personal data. While answering, discuss candidate generation, ranking, collaborative and content-based signals, offline training, online inference, feature freshness, experimentation, cold starts, latency budgets, and privacy considerations. Question 6. How would you ensure consistency when a user updates their Netflix profile across regions? I would classify profile data by business requirement. A name or avatar can use asynchronous replication and tolerate brief staleness, while entitlement or parental control changes need stronger guarantees. Each record would carry a version, and rights would be idempotent. After an update, routing reads to the right region or using session version tokens can provide read your rights behavior. I would monitor replication lag and define explicit conflict resolution rules rather than hiding inconsistencies. Make sure to cover strong versus eventual consistency, single writer or multi-writer choices, replication lag, conflict resolution, versioning, read your rights guarantees, retries, and which profile fields require transactional behavior. Question 7. How would you build a resilient API gateway for Netflix clients? The gateway would authenticate requests, enforce authorization, validate schemas, route to backend services, and apply quotas before business logic runs. I would deploy it as stateless instances across zones, use local rate limit enforcement with centralized policy distribution, and set strict downstream deadlines. Correlation IDs, structured logs, and distributed traces would support diagnosis. Versioned contracts protect older devices. The gateway should remain thin, concentrating business logic there creates coupling and operational risk. In your answer, discuss authentication, authorization, routing, rate limiting, request validation, protocol translation, timeouts, observability, versioning, and how the gateway avoids becoming a single bottleneck. Question 8. Describe how you would implement rate limiting for a public Netflix API. I would use a token bucket because it permits controlled bursts while enforcing an average rate. Limits could apply per account, device, IP, and endpoint, with stricter rules for expensive operations. For distributed enforcement, a shared low-latency store or region local quotas with periodic reconciliation are options. The API should return a clear 429 response and retry guidance. If the limiter fails, safe defaults and endpoint-specific fail open or fail close decisions prevent abuse. Be sure to explain token bucket or leaky bucket algorithms, per user and per IP limits, burst handling, distributed coordination, response headers, fairness, abuse detection, and behavior during limiter outages. Question 9. How would you design Netflix's watch history event pipeline? Clients would emit versioned playback events containing user, profile, title, position, device, timestamp, and an ID impotency key. A durable log partitions by profile or account to preserve useful ordering, while consumers process events independently for recommendations, resume playback, and analytics. At least once delivery is practical, so consumers deduplicate by event ID. I would retain raw events for replay, handle late arrivals explicitly, encrypt sensitive fields, and monitor lag and schema failures. While answering, cover event schemas, partitioning, ordering, at least once delivery, deduplication, durable storage, stream processing, replayability, late events, privacy, and downstream consumers such as recommendations and analytics. Question 10. How would you test a microservice before deploying it to production at Netflix? I would start with fast unit tests, then integration tests against realistic databases and message brokers. Consumer-driven contract tests would protect API compatibility, while load tests validate latency and saturation limits. I would inject dependency failures and verify timeouts, fallbacks, and recovery. Deployment would use a canary with automated comparison of error rate, latency, and business metrics against baseline. A tested rollback path matters as much as the release itself. Make sure to cover unit, integration, contract, load, resilience, security, and end-to-end testing, plus canary releases, automated rollback, production-like dependencies, test data, and meaningful service-level metrics. Question 11. What would you monitor for a Netflix playback service? I would monitor request latency, traffic, errors, and resource saturation, then add playback metrics, startup time, rebuffer ratio, bitrate switches, playback failures, and concurrent sessions. Dashboards should break results down by region, device, ISP, title, and client version. Distributed traces connect a playback failure to API, authorization, or CDN dependencies. Alerts should reflect user impact and sustained trends, not every transient spike. Synthetic playback tests provide an independent signal. In your answer, identify golden signals, playback-specific metrics, dependency health, regional segmentation, alert thresholds, dashboards, tracing, and distinguishing user-impacting symptoms from infrastructure-level causes. Question 12. How would you perform a canary release for a critical Netflix service? I would deploy the candidate version alongside the stable version and route a small, representative percentage of traffic to it. I would compare latency, errors, saturation, and business outcomes against a matched baseline, segmented by region, device, and endpoint. Automated gates would pause or roll back the release when thresholds are exceeded. The service and database changes must remain backward compatible. After confidence improves, I would expand traffic gradually rather than jump directly to full production. Be sure to mention traffic segmentation, representative cohorts, baseline comparison, automated health checks, business metrics, gradual rollout, rollback triggers, data compatibility, and avoiding biased conclusions from a small canary. Question 13. How would you design a caching strategy for Netflix metadata? For catalog metadata, I would use cache aside with regional read-through caches and a durable source of truth. Entries would have TTLs, versioned keys, and event-driven invalidation for urgent changes. Request coalescing prevents many misses from rebuilding the same hot item, while revalidate protects latency during refreshes. Negative caching can reduce repeated misses, but requires short TTLs. I would track hit rate, origin load, freshness, and tail latency rather than optimizing one metric. While answering, discuss cache-aside behavior, TTLs, invalidation, hotkeys, regional caches, negative caching, stale reads, stampede prevention, consistency requirements, and measuring hit rate alongside user latency. Question 14. How would you prevent duplicate billing or subscription changes during retries? I would require a client-generated idempotency key for each logical billing operation and persist it with the requested outcome before calling the provider. Repeated requests return the original result instead of creating another charge. Subscription state would use explicit transitions and transactional updates, while provider callbacks reconcile ambiguous timeouts. A background reconciliation job compares internal and external records. Every transition needs an audit trail, because correctness and supportability are equally important in payments. In your answer, cover idempotency keys, transactional state transitions, payment provider semantics, durable request records, reconciliation jobs, timeout ambiguity, retries, and auditability for customer support and financial reporting. Question 15. How would you optimize a slow endpoint serving Netflix's homepage? I would first trace the request end-to-end and decompose latency into gateway, database, recommendation, catalog, and serialization time. Then I would parallelize independent calls, cache stable catalog data, reduce payloads, and remove unnecessary fanout. Database query plans and indexes deserve verification rather than guesswork. I would protect tail latency with deadlines and fallbacks for optional sections. Finally, I would load test the change and confirm P95, P99, and user-facing metrics improve. Make sure to cover profiling, latency decomposition, parallel requests, caching, payload size, database indexes, fanout control, tail latency, tracing, and validating improvements with load tests and production measurements. Question 16. How would you migrate a Netflix service from a monolith to microservices? I would not split the monolith by technical layers. I would identify cohesive business capabilities with clear ownership and scaling needs. Using the strangler pattern, I would extract one capability behind a stable contract, route selected traffic, and compare behavior before removing old code. Each service should own its data where practical, with events replacing hidden shared state coupling. Strong observability and rollback are essential. Microservices add deployment and operational cost, so boundaries must earn that complexity. Be sure to mention domain boundaries, the strangler pattern, data ownership, incremental extraction, contract testing, observability, compatibility, operational overhead, and criteria for deciding whether decomposition is justified. Question 17. Tell me about a time you disagreed with a technical decision and how you handled it. On one project, I disagreed with introducing a new database because the existing system met current scale and the migration risk was high. I documented projected traffic, query benchmarks, and operational costs, then proposed a smaller indexing and caching experiment. The team reviewed the evidence and chose the incremental approach. I supported that decision fully, added monitoring, and revisited it when growth changed. The experience reinforced separating personal preference from measurable engineering constraints. In your answer, use a specific situation, explain competing constraints, show respectful disagreement with evidence, describe the decision process, quantify the outcome, and demonstrate ownership after the final choice. Question 18. How do you decide when to prioritize speed of delivery versus technical quality? I assess whether the decision is reversible, customer-facing, security-sensitive, or likely to create compounding maintenance cost. For a reversible experiment, I may ship a narrow version quickly with tests, metrics, and a cleanup owner. For irreversible data or payment changes, I slow down and require stronger design and review. I make trade-offs explicit, document debt, and set a follow-up date. Speed is valuable only when reliability and learning remain protected. While answering, discuss customer impact, reversibility, risk, minimum safe quality, debt documentation, staged delivery, operational safeguards, and how you communicate trade-offs rather than treating speed and quality as absolutes. Question 19. How would you design a feature flag system for Netflix services? I would separate flag configuration from application deployment and support targeting by account, region, device, or percentage cohort. Services should evaluate flags locally from a cached, signed configuration, avoiding a network dependency on every request. Updates need versioning, audit history, and rapid propagation for kill switches. I would define default safe behavior if configuration is unavailable. Every flag requires an owner, expiration date, and cleanup plan to prevent permanent conditional complexity. Make sure to cover targeting rules, gradual rollout, evaluation latency, local caching, consistency, audit logs, kill switches, flag lifecycle, security, and preventing stale or conflicting configuration from harming users. Question 20. What does Netflix's culture of freedom and responsibility mean to you as an engineer? To me, freedom means engineers receive enough context to make decisions without waiting for constant approval. Responsibility means owning the consequences. I would clarify goals, investigate alternatives, communicate risks, and make a decision appropriate to my scope. I would seek review for high impact or irreversible changes, then measure outcomes and correct course quickly. That combination encourages innovation without lowering standards. It also requires candid feedback and accountability when an outcome falls short. In your answer, connect autonomy with context, judgment, accountability, candid feedback, high performance, customer impact, cross-team communication, and knowing when to seek review or escalate operational risk. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.